Uncertainties for multiplication and division problems are different from uncertainties for addition and subtraction problems. So for this problem where we have to find the area of a square wafer, you're going to go ahead and list out both the width and the length here. So the width we'll say is 13.291 plus or minus 0.001 centimeters. The length is 12.1 plus or minus 0.1 centimeters. Now, what's the best estimate for its areas and its uncertainty? So this is, again, a two-parter. Finding the area, or I guess the best area, is the same as how it was always done. Basically, you're going to take the width times the length. That's it. So the width times the length comes out to be 160.8211. Now, if you want to take this with significant figure propagation with multiplication is such that the answer should have the same number of significant figures as the components that brought you the answer with the least amount of significant figures. So the length has only 3 significant figures, the width has 5. So we will have only 3 significant figures for the answer. The answer is then going to be 161 centimeters squared. The second part is finding the uncertainty. The uncertainty propagation with multiplication is a little bit more complicated. What we're going to now first do is define an uncertainty that's it's basically relative uncertainty. Delta W over W is a relative uncertainty. So that value is going to be 0.001 centimeters divided by 13.291 centimeters. The relative uncertainty for length is going to be 0.1 centimeters divided by 12.1 centimeters. So here's the equation for finding the uncertainty of area. Basically, what we have is the uncertainty for area divided by the area is equal to the uncertainty for width divided by width plus the uncertainty for length divided by length. In other words, the relative uncertainty of the area or of some function of width and length is equal to the sum of the relative uncertainties of all the components that went into that function. So if you're multiplying width and length, then the relative uncertainties of length and width are going to be added together to find the relative uncertainties of the answer as you multiply length and width. This goes for anything. So if you also have, say, a volume being length times width times depth, then the relative uncertainty of the volume is going to equal to the sum of the relative uncertainties of length, width, and depth. So there will be 3 terms instead of 2. And this goes on forever as long as you have multiplication or division. So if you want to divide by mass for some reason, you would also have a mass term, a relative uncertainty for the mass term. Now let's go back to this problem at hand. For this, this value is going to end up being something very small, 0.000075239. This value is going to be slightly bigger, 0.008264463. I'm just going to keep on putting all those numbers down because we're not reducing them yet. So therefore, the relative uncertainty for area is going to be the addition of the two. So that would then come out to be .008339702. Now the last step to take is to just find the uncertainty for area by itself. So you multiply both sides by the actual area to get that. Let's go ahead and multiply it by the area that came from the calculator, not the reduced version of it. So multiplying this value by the area of 160.8211 is going to be 1.3412, and then so forth and so forth. Now, again, since we're taking the addition of two values, which actually came from the multiplication of these, to find the number of sig figs needed is going to be a little bit more difficult. So what we're going to do is skip that because it's actually not necessary for this class. You can go ahead and write a certain number of sig figs that you find reasonable for the answer and for this error. So for the actual final answer and the uncertainty, we're going to have 160.8. Let's just say that's a reasonable amount of significant figures, plus or minus 1.3412. And the value or the unit is going to be centimeters squared. Another way of dealing with this, by the way, and you can skip a few steps if you'd like, is by simply just taking the relative uncertainty of all terms leading to the answer and just multiplying it by the answer straight up. That will just give you the uncertainty of that answer right away. Okay, so you can just skip a step and just multiply all relative uncertainties added together by the best value of the area or volume or density or whatever you're trying to find. And that will give you the uncertainty for that particular quantity.